Hello everyone, welcome to this session number 13, Introduction to Statistics, Visualizing Data with the Charts and Graphs. So this is a part 3 of histograms. Okay, so this is about me, and this is my LinkedIn ID. You can follow on LinkedIn. Okay, so these are all the ways we can organize the data: quantitative, qualitative, numerical, and so we are focusing on histograms. Now in the previous session we know how to construct the histogram, right? So whenever you have histogram, the first thing you should keep it in mind that we should have continuous class intervals. Okay, if the given class intervals are continuous, then we take these class intervals along with x-axis, right, and a frequency along with the y-axis, right? So then according to the frequency, then we draw the rectangular bars. That will be your histogram. Clear? In the previous session only I said histograms can be of two types. One is having the uniform class width. That means every the throughout all the class intervals your class size or class width will be same, right? Then the second type of histograms can be class width or class size will be different, right? Now whether it is of the first kind or the second kind, the first the very important thing we should keep it in mind that the areas of rectangular bars rectangular bars should be proportional should be proportional to the frequency. What is the meaning of this? Meaning of this means if it is, so let's say suppose here the frequency is 7, the frequency is 10. What is the meaning of this? Area of the rectangular bars should be proportional to the frequency. That means if I find the area of this rectangle, let's say that is R1, okay, and you find the area of this rectangle R2, so R1 should be less than R2. Why? Because it is having greater frequency than this frequency, right? If a frequency is more, that means it should have more area. So that is the meaning of the this sentence: area of the rectangular bars should be proportional. Obviously when you have uniform class width, so then there won't be any issue because the class sizes are same. So therefore then obviously if a frequency is more, then you will find the length will be more. But when you have this kind of scenario here, where here you can see here this is 20, this is 10, this is 10, this is 10, 10, and here 10, let's say about till 100, so then it will be 30. Are the, so here you can see the class sizes are different, right? So now here like how we will draw the histograms, so similarly I have drawn in the similar way, right? So this is the histogram. Now you tell me here, is this histogram, the histogram I have drawn here, is it correct? Is it correctly representing the data? So what is the mistake I have done here, right? I followed the steps only, I didn't do any kind of mistakes, I just followed the steps, right? I have taken the class sizes along with the x-axis and the frequencies along with y-axis. So I represented, so then I have taken the corresponding frequencies, right? So this is the histogram I got. Now you tell me, is this histogram correctly representing the data, right? How we will check? As I said, we just find the area of this rectangle. So the breadth is how much, the length is how much, 7, and the breadth is how much, 20. So therefore it is 140. Now look at this. So this breadth is how much, 10, and the length is how much, 10. So it is how much, 100. Now you tell me, is the frequency is 7, right? So that means this rectangle should have less, but it is having higher frequency, right? So this rectangle is having higher frequency, which shouldn't be, right? And now let us take this one also. Now here, what is the breadth here? 30. And what is the length here? So the length is 8, so it is 240 the area. What is the frequency here? 8. What is the frequency here? 15. So this rectangle should have more area compared to this rectangle, right? But here what is happening? 15 into 10, which is equal to 150, right? This is having more area. So that means whatever the histogram I have drawn, this is not correctly representing the data, right? So whenever you have different class width, you should be very careful, right? So you should make sure that all the rectangular bars or areas of those rectangular bars are proportional to the frequency or not. That you need to be rechecked. Okay. So now when you have this kind of scenario, what we do, we will make certain modifications in the length, that means in the frequencies, right? Such that the areas of those rectangular bars again proportional to the frequencies. Clear? So how we will do? We will consider the given data. Then we have two steps. What is the first step? We will consider the class interval or minimum class size. Our target is to identify what is the minimum class size of all the class intervals. Among the given class intervals, which class interval, what is the class minimum size, right? So that you need to identify. Once after identifying, what we do, we will convert all the lengths, that means frequencies, proportional to that minimum class size. That is the second step. So now let us do. Okay. So first we will write the class size or class width. What is the class size? Class width is nothing but the difference between upper and lower. Upper and lower. So this is 10, 10, 10, 10, 10, and this is how much? 30. Right? Now you see these are all having the different class width, right? That we know. Now you identify what is the minimum class size. Minimum class size is 10, right? So now what we do, we will try to convert these frequencies proportional to this minimum class size. How we can do? So that can be done. You take the original frequency 7, divide with the class width, corresponding class width, and I want to make it proportional to the minimum class size, that is 10. So therefore this will be 3.5. So similarly, take the frequency, corresponding frequency, then divide with the corresponding the class size. Then I want to make it a minimum class size, that is 10. So therefore it will be 10. So similarly 10 upon 10 into 10, so which is equal to 10. So 20 is the frequency and the class size is 10. I want to make it proportional to 10. So therefore I am 20, 20 and 10. right, into 10, so which is again 20. So here the frequency is 15 and class size is 10. I want to make it to 10, so therefore it will be equal to 15. Now here 8 and class width is how much, 30. So I want to make it proportional to 10, so therefore it will be around 2.67. Now these are all my new frequencies. Okay, so now let us construct the histogram with the new frequencies. So how we will construct? So here we will take again the same. Okay, so here I'm taking this color. So okay, yeah, so the class interval is 0, 10, 20, 30, 40, 15, sorry, 50, 60, 70, 80, 90, 100. Okay, so these are all the our new frequencies. So you can take the scale of 2, 2, 4, 6, 8, 10, 12, 12, so 14, 16, 18, 20. Okay, so now let us construct the histogram. Okay, so 0 to 20, how much? It is a 3.5. So 3.5, this is 3.5, right? And the next to 20 to 30, it is 10. This is 10. And next to 30 to 40, again it is 10. 40 to 50, it is 20, right? So 20 is this, the highest one. Okay, and next is also again 20. Okay, so next is 15, so I'll make it here. Okay, next 70 to 100, it is a 2.6, this one, right? Okay, now if you check, okay, it should be, the area should be proportional to the frequency. So now here, if you draw it on the graph sheet properly, so then the histograms looks like this. Now try to check. So now here, what is the breadth here? It is 20. And what is the frequency here? 3.5. Okay, so 2 5 is a 10, 2 3 is a 6, 7, so 70, right? So now here the frequency is the area is how much? 10 into 10, so which is equal to 100, right? So this is having greater frequency compared to this, so therefore the area of this is greater than, right? So therefore our histogram is correct. So similarly you can verify for this also, right? So that is the way to construct the histogram. When you have uniform, so there is no issue, but when you have different class width, so then you should be you should recheck whether the areas of the rectangular bars are proportional to frequency or not. Clear? Yeah, yeah, so that's all for this session. Thank you, and like it and comment, and you can ask anything you wanted to, like a particular chapter or particular concept. Okay, and share my channel and subscribe. Okay, thank you.